Hey everyone, just want to do a quick mini series on Guideline 36, starting with the fundamentals of the algorithms of Guideline 36. So this YouTube video, it's a bit long. It'll cover some really basic algorithms that aren't even useful in the real application, but I think it's important to know like the fundamentals of a true Guideline 36, what's happening behind the scenes. I'll basically walk through with a program object how to find the maximum value in an array of data, ignoring the top highest values, and also a ping-pong counting algorithm, which you see here. So this is YouTube video is about an hour long, vibe coding all of this. So it's kind of the fundamentals of Guideline 36. If we can accomplish an algorithm, as you can see, it'll count up to 10 and it'll count backwards to minus 10. It'll count up to 10, it's minus 10 and so forth. So it's kind of like the fundamentals of what happens behind the scenes in Guideline 36. So if we can understand this, it'll make the following videos of the actual implementation of Guideline 36 much easier to understand. So this first video will be the fundamentals of the algorithms. The second video will be the actual implementation of the Guideline 36 on air handling unit system, duct static pressure, and temperature reset. And the third video I think will be related to chiller plants and also fault detection defined by Guideline 36. So it's kind of long and drawn out, so feel free to fast forward through some of the vibe coding processes as they did get a little bit, took about twice as long as I thought it would. So I apologize for that. So feel free to watch it on ×2 speed, but we ended up getting it in the end. So just a little bit about this, the kind of the theory behind what I'm trying to do. So like when we're looking at Guideline 36 energy efficiency concepts for an air handling unit, a variable volume air handling unit that serves VAV boxes, there's a variable fan right here on the air handling unit that's on a VFD with a static pressure sensor. There would also be a leaving air temperature sensor, and when we are doing concept algorithms, like filtering values, maximum values in an array of data, like what I'm referring to is zone level data. So this should be an air damper position on the VAV system. Like the algorithm in the real world would look at all these different air dampers, and then we would filter for the maximum values that we're looking for in the algorithm. And then also in the ping-pong algorithm, that we demonstrate the basic concepts of how to reset a static pressure reset, for example. We're actually resetting between minimum and maximum values of how the fan on the air handling unit system would control to a duct static pressure. So this YouTube video, like I mentioned, doesn't get into the actual nuts and bolts of Guideline 36, but it's actually just talking about the fundamentals of how we get there. So, and also this is kind of a neat image from the MEP Academy, which I thought they did a really cool job. So I was just looking at their website for pictures of air handling units. So great job, MEP Academy. Stay tuned. Hey, what's up YouTube? Just here to maybe talk a little bit about algorithms. I was thinking about adding a couple more generic algorithms to the vibe coder repository. So yeah, let's kind of recap what we got here. Yeah, I've been kind of reorganizing things a little bit, and then have some kind of some generic algorithms. One thing I want to do is kick controls T-stat block, but kind of make it a true deadband, and some more of the easy stuff. I have added some more advanced, querying APIs on the internet, some concept ideas with calendars, this is something I want to do down the road too. It's open automated demand response version 3.0, which is somewhat new, which is more like in demand response, there'd be like a box, like an edge device. It could be a Jace, and it can talk to a demand response server, and it will send events to the building to turn off the air conditioning. It can be any kind of strategy that the demand response program has. It's kind of rare that buildings are even incorporated in demand response, but I've worked a little bit in that area and think it's kind of neat. And also Pacific National Labs has some kind of advanced Voltron system. So they have an intelligent algorithm that kind of keeps power below some power threshold. So these are more demand side management strategies, kind of advanced stuff I want to do down the road. I want to come back to these calendar ideas at some point in the future. But I also think it's worth maybe just doing some generic algorithm stuff, some of the simple things. I am actually running these Guideline 36 trim and respond ductile pressure algorithms in the field, and also these two different these are optimal start. So this is the same thing that Kick Control Energy block has. They have their own optimal start built into the Workbench tool. We can make our own based off of later and better research, because some of the Kick Control widgets might be pushing about 20 years old, and there's better research since the days of Niagara AX. So I am actually using these in the field. Even this is just a block that I made in a program object that looks at all the different valve positions for the chiller plant, and decides if the chiller needs to come on based on valve position or demand. All right, so let's talk about just some generic algorithms that I can add into more of to the vibe coding repository. All right, so I'm going to jump right into it. So this is I have some generic algorithms that aren't very useful in ordinary HVAC. Like, you wouldn't be doing this in the BAS, but it does kind of lay the framework for Guideline 36. Guideline 36 for air handling unit trim and respond is it's lots of counting up and down, filtering out maximum values, and it's kind of hard to do in wire sheet logic, which I'll demonstrate here. But so this is just a wire sheet algorithm that I made, just an ordinary Kick Control widgets. So this is the top 5 of 15. So they're labeled as VAV box damper positions, but so this is where you kind of use it for. Like, if we're starting down the road of Guideline 36, we would potentially be looking at an air handling unit system. So every VAV box damper position in the system, like, we would be monitoring those damper positions in Guideline 36. If we're doing trim and respond on the air handling unit duct pressure set point, we would be filtering for the filtering out some potentially rogue zones that would interfere with the algorithm's performance. So this is just a generic algorithm, kind of hard to do in wire sheet logic, which I'll demonstrate, but it's fake data. So these are just, they're not connected to anything, but so this is like the fake data starts at 10 and then it goes all the way up to 150. So values of 10, it kind of works its way up. And then that's where you see on the other side, the maximum value is 150. The top highest one is also 150, 140, 130, 120, 110, and so on. So if I manually change this to, let's change this one, 200. So the control logic finds that the maximum value is 200. Top value 200, and the second highest is still 150. So I could even put this one at 300. So the filtered max is now 300. The top highest value is 300. The second high is 200, 150, 140, and so on. So this is something that we would kind of potentially do in Guideline 36 is depending on the air handling unit system, we would be filtering out this maximum value if there was a rogue zone. So then the algorithm would potentially control to lower values when we'd filter out the stuff we don't want to use. So this is and to do this in wire sheet logic, it takes like lots of if-else statements, comparator blocks. It's a lot of code, a lot of wire sheet logic to implement all this. It can be kind of daunting to set it all up, and then we finally get to a final comparator block that'll feed out these all these values, and then we'll see that in here, right here. So we can do this in Java, and it would be much cleaner and easier. Even though wire sheet logic is can be easier to troubleshoot. These are, this is just can be daunting in itself, even just making it, but using more like computer science patterns in Java, you'll see it's just a few lines of code. We can do the same thing, much more cleaner and easier. So I am going to download the README. Let's go to the README on GitHub, and I'm going to hit this download button right here. See it downloaded. Let's go over to ChatGPT. Let's go find that in our downloads, and then we can ask it what we want to do. So I could even take a screenshot of this wire sheet logic. Where are you? Gotta find my snipping tool here. 1 second. So it's something, more info you give to ChatGPT, the better. Okay, so it has the model contacts and the README. This is optional, you don't have to do this. So let's work with ChatGPT now to tell it what kind of algorithm that we want. So let's say I want a program object that is a generic top 15, that is the top 5 values in 15 filter, filtering out the maximum values. There is also a screenshot for how this was done in wire sheets, where 15 values are fed into the block, and then the right hand side we are finding the top 5 highest values, and there is also an input for the filtered max. Please make me a program object that can do this, please. Alright, there should be enough context for the ChatGPT to do this. Now it's reading the context. So yeah, it's thinking. In the meantime, let's see, I can probably, let's make a new folder. I'm gonna say, oops, not what I wanted to do. I just want to do actions, new folder, top 5 in 15, program object. Actually, you know what I'm gonna do? I'm gonna do something different. I'm actually just gonna duplicate this, so then I can use some of those variables as input. So program object. Okay, so this is when we'll use a program object. I'm just gonna say bye-bye. So now we just have some generic inputs, and then we can potentially link everything to. So then I'll probably come down here and let's go to our program. Let's drag out a program object. Okay, so let's see, maybe ChatGPT's done thinking. Okay, here we go. So this is our slots that we need to make. So it's telling us if status numeric, status booleans. Here's our code. Let's look at our code. So, all right, so we'll have a timer that's like a heartbeat that I've been using on all the other algorithms I've been making. This will actually put the slot back to null if you disconnect a wire, which we should test too. So this will be our top 15 inputs. These are just some generic tests. Reading the data. Some check if the value is empty. Then this is just like where some of the math, I guess, is buried in here. So it'll drop the max value based on what we feed it in. Yeah, let's try this out. And then we'll also have, it looks like a string output too. That's kind of nice for debugging purposes. So let's copy that. Here, go back to the program editor, paste you in there, and then we'll have to do some busy work in slots. Okay, so here we go. So parameters, ignore below. Okay, so we have to make status numeric inputs 1 through 15. There we go. So input 1, we do a summary, then these are going to be status numeric. And there's also like an execute on change and read only and an operator, but I mostly just do a summary and status numeric. I'm going to quickly do this. This will already count upwards for the next values. So I'm going to step through here, go all the way up to 15 here. So bear with me. Nine, 10, keep going, keep going. Okay, we got our 15 inputs. So just to show you what this will look like now. See, we got our inputs that we can then wire in on the side. So then our next ignore below. So it looks like we have ignore below. Makes no sense to me what this is for. Ignore below. Default value 0. Drop any values that are less than ignore below. So let's try it out and see how this algorithm works. Program editor, slots. Ignore below, another status numeric, drop global max. So it looks like ChatGPT's already thinking of like how the design of the algorithm would be. Okay, so then we need some status numerics. Also, these will be our outputs. We can make read only. So status numerics. Whoops. Rank. These will be our outputs. And I'm making them read only too. Rank 2. Like we have to go to 5. Rank. A couple more. So filtered max. The read only. Alright, so then here's this used count. So this will just be for diagnostics. Curious to see what that's supposed to be. Read only. And the status trace. Which is a string output. Alright, so this should be our block. See what she's looking like. So looking kind of like this. Status trace will be a string, so we can do string writable and call this status trace. Make this one a little bit longer so we can read it, and then we should compile it. Got some nice code. Alright, then hit the compile and save button. Alright, so ChatGPT is getting pretty good at it. As long as we named our slots right, no compile errors. If you do get compile errors, I have to screenshot with a snipping tool back into ChatGPT what's going on. So let's test it out. So let's ignore below for this guy. Let's do some wiring. So here we go. Filtered max. Filtered max. Used count. Let's see what this is supposed to be. Used count. 2 values. Looks like it's how many values that we're feeding in there. Looks like I missed one. I do not see anything counting yet other than this used count. No filtered maxed. But let's keep on wiring up some inputs. Another thing we can also test is that if you delete and it goes back to null, so we know our algorithm is kind of continuously checking if we have wires connected, which is good. Keep going. Couple more. Oops. I have to slide this guy down here a little bit. Alright, so a few more. Does not look like our algorithm is really responding yet, but let's see what we got here. Null. Alright, so connect our values up here. Alright, and then we even have our status trace. So I also got keeping application director open, no errors in there. So used, ignore below, global max, drop global max, filtered max is 300. So what I'm seeing here is that the status trace is working, but I'm not seeing values coming through here. So let's just set one of you to 400. Yep, so let's see. So it is working. So there's the filtered max. But what I am noticing is that our values are not populating here. Unless this, unless we're doing something wrong with our input variables. So Actually, filtered max is 400, but we have an ignore variable set of 1. So that should be ignoring 400 and going back to 300. So notice a few things wrong in this. Let's take a screenshot here. Go back to ChatGPT. So let's say we observe. So like I observe the algorithm is not counting as expected. The right hand side ignore variable is set to 1, but it is revealing in the status trace that the top value is 400, which is correct, but it is not the filtered max value, which would be 300 if the second highest value was being measured. Also, on the right hand side, the ranked outs are not populating with data at all. They are 0. Please revise. Okay, let's see what it does. Like I was saying before, this is kind of not useful in the practical world, other than kind of getting a little bit closer to what we would do in Guideline 36. So we're just kind of marching down the road towards Guideline 36 algorithm, which I'll demonstrate here in a little bit eventually. So okay, see what we got here. And ChatGPT is a little bit slower. Thinking. Make sure the screenshots. Rank is still reading 0. Keep your existing. Alright, slot same as before plus 1 new one. Parameters, ignore below. And new drop count. I wonder what ignore below is supposed to be. So it's telling us that they do a new drop count slot. So let's add in a new slot. Add a slot, a drop count, summary, status, numeric. Okay, so let's copy that and just ask it. So drop count is the filtered nth variable. Exactly, you got it. Okay, so drop count is what it's expecting. So it's just like computer science 101 theory, like we just take an array of data and it's going to drop out these values. Sorting an array, very basic computer science 101 going on behind the scenes. Let's go back to here, put this into here. Save. Oh, looks like we have compile error. Status numeric drop count. Looks like I think that's because the slot. That's a slot naming issue. Naming error. So let's handy dandy way of getting compile errors back into here. Remove this line completely. Okay, so let's move this line completely. See if we can find it. Sometimes if I'm lazy, I'll just have ChatGPT write me an entire new script, but I guess we can do the, so it's saying to remove that. Save, compile. Alright, let's test out our algorithm. So, still not seeing data come up on these ranked outputs here. Status trace. Okay, so I'm going to delete that. Drop global max. Ignore below. Whoops. Actually, I think it's okay, so it's it's minusing 1. So I'm gonna tell it to remove these ignore below and drop global max value because they're confusing. So let's ask it to revise again and just say please update in dropping the slot ignore below and drop global max, and just go off of the slot drop count and keep used count, please. So we're still not seeing these guys populate either. It's actually going a little bit slower than I thought. I thought this being pretty easy algorithm, I thought ChatGPT could nail it right out of the box, but still beats doing wire sheet logic. So, alright, here we go. Here's a trim programmatic so that only uses the drop count writable. Okay, removed ignore below and drop global. Okay, so we have to take these guys out. So we're gonna like delete these guys. Delete. So we're just gonna be going off these guys. Alright, now let's do some algorithm testing after this. Here we go. Copy some code. Bam. Save, compile. Okay, still not seeing these guys populate, but input's 15, drop is 1, use is 14, filtered max is 300. Okay, so it is computing correctly, doing the array sorting and filtering under the hood, but we're just not getting these to populate. So I'm happy that at least it's getting the basic math right. So let's just tell it, it looks like in the status trace, the basic math is good on filtering, but the ranked outputs are not coming through on the slots rank 1 underscore highest, 2 underscore highest on the slots rank 1 highest, and so on all the way through 5 based on what is getting filtered. Alright, let's see if we can nail it after this. I feel confident. Ooh, it looks like the wire names don't match. I could have done is screenshot the slot sheet too, which also helps. Actually, well, let's see what it says. I don't think that is correct. It thinks that it's troubleshooting a few things. I don't think that's right, though. Come on. The internet doesn't get any faster. So I think we just have like a slot naming issue. Just watch it right. Writing some on start method, on execute. So it's getting the values that we wire into it. It's creating an array that has a double data type for each input. And it's for looping through each value in the array. It's getting a value for the counts. Looks like it loops through. Alright, let's see if it gets it right this time. Here we go, we got some Java code for us to test. Go back to program editor. Boom. Alright, let's test it out. Here's our inputs. So it is like it's not writing this why aren't you writing? Yay, this guy's kind of fun. This is kind of interesting. So alright, so let's just see like what's going on here. Let's try and let's tell program compiles fine, but no data is getting written out on the ranked highest values once they are filtered, because we want a filtered max. Max values. So, okay. Nothing. We should be getting data populated out here. So, I'm going to tell it string writable. String writable is getting the correct string written, but nothing on ranked. I'm just going to say, please make an easy array where we just filter the maximum sorted values in an array. pretty basic stuff. Surprised it hasn't figured this out yet. Either that, we can fire up Gemini. Sometimes I use Gemini in this too. Can't hurt to get Gemini prepped if I can't solve it. On this last go around, let's give ChatGPT one more try. One more try for ChatGPT. I think in the meantime, I'm gonna just start prepping Gemini. Start putting values into you. Program object code. Maybe one for my slots. Alright, let's see if it gets it. Out of there because we're going to try this ChatGPT's logic one more time. Boom. Ooh, compile. Put you back in the ChatGPT. Alright, ChatGPT, you got one more try. So replace the set OK method. It's wanting us to revise this code here. Alright, well this is not going very well. Let's see if Gemini can fix it. Need help on this algorithm that filters maximum values and then populates output variables into ranked highest 1 through 5, including a status, trace, and count value. Alright, let's see what ChatGPT is getting fired for the moment, and we're going to switch to Gemini. Kind of a little bit disappointing, but sometimes it's just the way this goes. Is the fun of vibe coding. Alright, so this is interesting. A B status not okay, so let's try this set okay. Missing drop count. I don't want to drop count. Alright, so it's going to fix the code for us to set okay. So I'm going to tell I don't want a drop count slot. And the only ones I want is filtered maxed used count, filtered max. The only ones I want is filtered max, used count, ranked 1 through 5 once filtered, and the status string. Please update again with the correct set. Okay. Alright, let's see what it says. Alright, so we got here, should be pretty simple little algorithm here. Got go compile. Ooh, here we go. Look at this. We got some values populating. Go Gemini. Alright, so then this is the fun part of vibe coding, is like we should be testing the heck out of our algorithms. And let's test the heck out of it. Alright, so we're saying, I can already see something is wrong here, is that the ignore variable is set to 1 and our used count is only 13. So let's set u to 0. So if our ignore variable is 0, we should have 15 values wired in, and our used count should be 15. Alright, so I'm going to tell it we got the bug here. Let's just try testing this to 5. Yeah, it's not updating at all. Alright, so we got some data. Our ranked values are populating at least, so that's positive. But this slot is not. Taking a screenshot. The input slot drop count is not getting factored into the algorithm based on the drop count. If it is set to 0, we would ignore everything, and if it is set to 1, we would ignore that, the first highest, and so on to whatever drop count is set as. Please update again. Well, at least we're getting somewhere, that we're kind of filling out some values, and we are getting somewhat closer to using top 5 of 15 as wiresheet logic, and we're finally doing the same thing with raw Java code, which has been a little bit of a surprise. It's taking a lot longer. I thought we would get this done in about a minute or two, so it's actually kind of surprising that to me that it's taking this long. Okay, here we go. So top 5 of 15. So let's see, we got, oh yeah, use count. So this looks good. So I can see right now that I want to filter 5 values, and then it's saying we're using 10 values. 10 out of 15. So if I set this to 12, we would only be using 3 values. So based on the top, that looks right. So if we filter nearly all of them, use only 3, the top 3 would be 20, 30, and 40. So if I set U to 0, we'd be using all of them, and our filtered max is 500. So this is looking excellent. I feel satisfied. So let's do one more try at 8. If we filter 8 values, we are using 7, and yeah, that looks good. Have a nice status trace. So one thing that we can do here is just test if we have our inputs go null, if a wire is disconnected. Ooh, it looks like we have a problem. Pretty important that we want our algorithm to recognize a wire is disconnected. So getting better. So I'm gonna say, please reference the README. Everything works on the algorithm with the exception of when a wire gets disconnected, the value does not go null, where the algorithm would ignore a null input. Also, what is the internal timing? Yeah, so we definitely have an issue here. So I want to do some thorough testing here. Updated Java code. So, yeah, so it looks like it's check for disconnected wires. This will loop through any unwired and set it to null if it's not wired. Save, compile. Oop, null. Went right to null. Okay, so let's put you back in here. Okay, so if we put our filtered max, let's just keep testing. Where our most important thing is testing software for vibe coding. Okay, so our filtered max is 300. We're ignoring 1, 14. And then let's just disconnect you because you're nice and close. We went to null. We dropped one more on our count. Let's do another one. Let's drop this is our top highest value. We went to null. Top highest value is 150, so the algorithm is still working even when we're disconnecting wires, our values are going null. So I feel pretty good about this one. So I might even package this one up into the README for the vibe coder. Looks like we do have like some exceptions here, but let's just clear you and let's just run our algorithm through some paces and just check the application director again. I'm just doing a little bit of test just to make sure. Yeah, so those exceptions that happened in here were from something else. So, okay, so I feel pretty good. I might package this one up and put it into the README for more model context. Gosh, I just can't believe like how long this one took to actually get right. Took a little while. So, and when I'm actually exporting a bog file after I did some testing, let me just show you that real quick. Control T to do another tab, and then I'm just going to, this is my newest one, I'm just going to drag you right off of here, so then you can actually just find that in your file system. So this is my file system, and I will add this into the README. So thank you for watching so far. So the next one that I'm going to test in the video right after this is the Ping-Pong algorithm. So there's nothing too wild about this algorithm. That might be kind of fun to make into a program object. So this is what we're going to do next to add for more model context. There's nothing very crazy about this algorithm other than it's a counting algorithm, so we'll count up to a value of 5, and then we'll count down to a value of -5, count back up, count back down, count back up, count back down in these step sizes, also with a time interval. And yeah, so this is actually kind of hard to do in, can be kind of hard to do in Wiresheet logic. So let's see if we can do this in a program object. And we're getting a couple steps closer to what Guideline 36 is. Guideline 36 is basically taking the concepts of filtering values in an array, and then also concepts of ping-pong counting, with the ping-pong counting algorithm. So if we can master these two, we're at Guideline 36 complexity. So I'm going to stop the video here, and let's reconvene for the ping-pong counter. Thank you. Hey everyone, how's it going? Back again. So we got the top 5 of 15, just uploaded that to the Vibe coder repo, so it's working. So this will be added as model context, like we just demonstrated. It takes up to 15 inputs, filters out any null or unwild sources, publishes the top highest values, and like we tested, it checks for each input to be okay or null, it'll drop it. Also that it updates once per second internally, so that's how the algorithm works. And it also clears. Yeah, so that's working pretty good. So also the Java in here is here for model context. So we just added some more information for ChatGPT to use, and our ping-pong is our next one. So here's a to-do. Okay, let's see if we can do it. See if we can be fast about this. I did like how Gemini did seem to, I have noticed that I do kind of like Gemini a little bit better for some coding things. So let's, I'm just going to input it directly rather than downloading it again. All right, so we have this loaded in the Gemini, and we are going to, I can get rid of these. Just gonna close that tab, fresh, clean application director. Okay, so like the last video we were talking about, let's make a ping-pong algorithm. So for a ping-pong algorithm, we need let's set this to 25. This will be our upper limit. We have a startup, let's see, get the better name, startup delay. We don't really need a startup delay, but I guess we could. So this is our lower limit, minus 25. Okay, so this is, I'm going to put these next to each other so a little bit easier to understand. So upper and lower limit, startup delay, we're going to step only 0.25 each step, and update, let's put you to every quarter of a second. Let's see if we can update 0.25 between these two values. I can put a startup delay as 1. And the initial value, sure, of 1. That's fine. Enabled. And it looks like we're off to the races already. So having like some kind of a clear thing, I think I might need to put this at a slightly higher value. I'll show you in a second. 1. So if I put this as maybe 1.25. Okay, so in wire sheet logic, when I put things less than a second, it's not happy. So basically, I think you get the idea. Is like we're gonna count, see how we got up to the value of 25, and now we're counting downwards. And then we'll turn around. As soon as we hit minus 25, we'll start counting back up. So we'll just count back and forth between these two values. Here's our little output viewer. Another really basic algorithm here that's not super useful for the real world applications unless we're kind of getting towards the steps of Guideline 36. So like these step counting algorithms, min and max array value sorting, we're getting close, we're getting closer. So this is also done in wire sheet logic, which is kind of a pain in the butt to do in wire sheet logic. If you ask me, like we're having to use a multi-vibrator block that's pulsing values open and close, and this actually took me forever to figure out how to do in wire sheet logic. So it looks really funny in here, but there's like numeric latches. Like if we reach our upper and lower limit, we start counting upwards and then back again. So wire sheet logic gets kind of nasty. And I think we have enough data now to maybe try and see if AI can crank out a program object. So I am actually going to screenshot this. Paste that into Gemini. So can you make me the Ping-Pong algorithm in the program object, please? Same slots as the pasted snip where, let's see, I'm gonna look at this. Maybe I'll try and feel like I can describe it a little bit better if have the two things right next to each other. So we need a bool enable. I'm just gonna read these right off the initial value, lower and upper limit, startup delay in seconds, step size, and update interval. Seconds, and the output numeric read-only value of where the algorithm is counting. Make haste, please. Go fast. See if we can get this done. See if we can get this done in a half an hour. That would be the neat thing to do. Okay, so let's see. I feel confident. So while that's thinking, let's do the same thing where I am just going to duplicate you. Just go to program object variation. So like the last thing, I just ended up upper limit, lower limit. Suppose I can clean this up a little better, make it nice and neat. And then I'm just gonna delete you. We don't need any more wire sheet logic anymore. Let's see how nice and clean and easy just coding it ourselves. Computer science patterns, which I think is just like a little bit clean and easier way of doing things. I'm a bigger fan of these things the more and more I get to use them. So all right, so like same style as the top 5 and 15, we have a Ping-Pong algorithm, and these will be on the repo too for anyone that wants to try it out or reference it. These wire sheets will always be available for a pre-built log file as well. So okay, let's see what do we got here. Get back to Gemini. All right, here we go. Boom. What do we got here? So here's some code that we can test. All right, so here's our slots. So what I'm going to do is just copy Gemini, paste you in here. All right, let's just start going nuts with our slots. All right, here we go. Do some slots, status numeric, that'll be an input. Output value will also be a static numeric, but we can make that read only. Output value, so then here's our upper limit, status numeric. No, there's our lower limit. Upper limit, a status numeric, and here's our update interval in seconds. Update interval in seconds, and our step size. And I think that pretty much covers everything that we want to do. So let's see, date interval, initial value it did not do. I don't see an initial value. F, fail. What about initial value? Which is very important. So as we get into guideline 36, if we are resetting an air handling unit, temperature, pressure, it's very important that we would be, all right, so it says that there is a slot, but it didn't give it to me here. So, all right, so initial value. Compile button. Alright, so we're just gonna have to, there's another one. I can see it's missing our slot enable. So let's go back over here. Enable, just like our counting algorithm did in the wire sheet, which will be status boolean. Save and compile. Alright, what else do we got here? Clock schedule, mix seconds. Alright, we have to paste this into Gemini. So, actually, I wonder if we're missing another slot. Is that a slot that we're missing? Oh yeah, interval seconds. So, get component. I think we are just missing a slot. Gemini did not do a very good job at telling us what slots to delay seconds. Yeah, it's usually Gemini should do a little bit better job at telling us what slots we need. What slots are we missing? Alright. Addressing compile errors. based on the screenshot, you are not missing any slots. However, your other screenshot shows a compiler error. I see it as incompatible, lost in conversion, double to long, data type issue. So with initial decimal value for seconds, it expects a whole number for milliseconds as a long data type. All right, here we go. Compile it good. All right, let's test it out. So we got looks like enabled's going on the bottom. Initial value of 1. Lower limit, upper limit, startup delay, step value, update interval, seconds. Ooh yeah, look at you go, I can see it counting. Look at that count. Count. Let's see if we get all the way up to positive 25. We should reach our upper limit. And then we should start going the other direction as the ping pong would go. So test for vibe coding. Just remember that. Will we start counting down? Yes, we started counting down. So I might just put you at -5. So we don't have to wait that long. Ooh, and we start counting back up. Okay, great. So we have a good algorithm here. So let's just see what happens if you set you false. Do some more testing. We could do even an update interval. How the kit control widgets didn't like less than a second updating. Let's try a 1/10 of a second. Maybe let's just put you to some. Let's just try some like really weird long numbers. Maybe we can even put you at. See how good this will output. I guarantee this will outperform wire sheet logic counting. Let's see. So see how she starts counting now. Oh, look at that counting. Ooh, it's counting down fast, counting up fast. So boom, counting back up, counting back down. So I know this isn't anything very fancy, but it is the core concepts of Guideline 36. So like if we were, which we'll get to eventually, like if we were resetting the air handling unit duct static pressure set point based on trim and respond counting logic between a minimum and maximum values that the duct static would go, we need to set an initial value, a step size, if the algorithm is enabled, and also how fast we're updating. So this is getting to be the core concepts of Guideline 36 of the program object. Is we're filtering values from top highest arrays, top values in an array, which is a concept. So in Guideline 36, which we'll get at eventually, we will be ignoring our rogue zone, which we've figured out how to do that. And then in here, our ping-pong algorithm, we figured out how to do our step counting back and forth. And for the next video, we can probably jump right into Guideline 36 on the VAV box, how we'll define counting requests. So the VAV box will count, I need temperature requests, I need pressure requests, so we can go right into that. And as we can already see, if you use a program object, it comes through much more clean and easy. It's just like when you can do modern computer science patterns, and I know we're cheating quite a bit using AI. And as long as we're testing, I love testing, that it's just so much cleaner and easier than using this stuff. Oh, YouTube actually must have deleted my old Ping-Pong. No, sorry, these are backwards. I have to rename these, but using this stuff, it's gets kind of wonky, which I'll show you in a Guideline 36 version of this too. Thank you and stay tuned.